Good day, students. Welcome to a review clip on logarithms. So we're going to review some of the concepts that we covered last class. Okay, so write down the title for this lesson: Review on properties of logarithms. Properties of logarithms. Okay. All right. So let's take a look at some examples. All right. Given that log 5 is approximately 0.6990, log 7 is approximately 0.8451, and log 9 is approximately 0.9542. Evaluate the following logarithms. All right, number one, let's do log 50,000. All right, now one thing you want to note is as follows. There are no bases provided here. If there are no bases provided, that means that the default log, is base 10. So what you're going to do is put base 10. You can put base 10s here if that makes you happy, okay? If there's no log, the default log is base 10. So if we're dealing with base 10, what additional log can we assume, or is this problem assuming that you know? It assumes you know that log base 10 of 10 is exactly 1, because you know these two cancel out, so that's 1. So we know this. Alright, we always know the log of a number that matches with the base. Okay? Alright, let's go ahead and try this number. This is base 10. Now the game I'm going to play is I want to express 50,000 using any combination of these numbers. Any combination of these numbers, okay? So if I break down 50,000, I know you write down 50,000 strictly using 5 and 10, right? So I can write this as log base 10 of 5 times 10,000, right? That can be broken further into log base 10 of 5 times 10,000 is 10 to the 5th, right? Wait, 1, 2, 3, 4, 4 zeros. I'm sorry, 10 to the 4th. Or 10 times 10 times 10, 4 times. Alright, so what is multiplication in the log world? Remember, when you multiply in the log world, it's the same thing as adding. If you multiply in the real world, it's the same thing as adding logs, and then when you divide, it's the same thing as subtracting the logs, okay? So in this case, we're going to have log base 10 of 5 plus, because multiplication becomes addition of logs, log base 10 of 10 to the 4th. Alright, now let's simplify this a little bit further. Because of this exponent here poses a unique situation. I know log base 10 of 10, but I don't know what log base 10 to the 4th is, so well, we could figure that out in a minute. So what is log base 10 of 5? The approximate value, this is equal to that. This is going to be approximately, log base 10 of 5 is 0.699 plus log base 10 of 10 to the 4th. This, you can put this to the front, or you can just cancel them out. If I cancel, well, let me just bring this to the front, okay? If I bring this to the front, it's going to become 4 log base 10 of 10, right? So this whole thing reduces to 1, so what you're left with is 0.699 plus 4, because these ones cancel out to just 1, and 4 times 1 is 4. So your final answer is approximately going to be 4.699. Okay? Another way you would have done this, the longer way you would have done this is just writing log base 10 of 5 times 10 times 10 times 10 times 10 4 times. And then you can go log base 10 of 5 plus log base 10 of 10 plus log base 10 of 10 plus log base 10 of 10 plus log base 10 of 10, and then this one becomes approximately 0.699 plus 1 plus 1 plus 1 plus 1, because all these are just ones, right? And then you're going to get the same answer. This is the long way of doing it. This is like a quicker way of doing it. All right, so both of them will give you 4.699. So whichever method you prefer, you can go ahead and use it. All right, so there you have it. All right, let's go ahead and try another example. Example number 2. We're going to do, for number 2, we're going to do log of 0.0007. So number 2, what is log 0.007? 0.0007. Okay, so let's see what we have. So to deal with decimals, we have to use a unique trick here. Remember, this is log base 10. What I'm going to do is, I'm going to take the decimal and divide it by 1. The reason I'm doing this is I want to keep my decimal points nicely organized. So divide it by 1 point. Okay, so if I divide anything by 1, it doesn't change it, right? Because this is an identity of the division. I want to get the numerator to become a whole number or an integer. So by doing that, that also affects the denominator. So how do I get this to become a integer? I need to move the decimal point 1, 2, 3, 4 places to the right. That makes it top 7, right? So if I move the numerator 4 places to the right, I need to move the denominator 4 places to the right. 1, 2, 3, 4. Bam. So I put a 0 here, put a 0 here, put a 0 here, put a 0 here. So now that's going to become log base 10 of 7 over 10,000. You see that? I know log 7 and I know 10,000. So this one's basically going to be log base 10 of 7. 10,000 is what? 10 to the 4th. So what is division in the log world? Division is subtraction, right? So this is going to become log base 10 of 7 minus log base 10 of 10 to the 4th. Okay, so we can bring this 4 to the front, and these two are going to cancel out to make this 4. So this is going to be approximately, log base 10 of 4 is 0.8451 minus 4, because these two cancel out. Okay, so what is that going to be? I have no clue. Let us fire up our calculators and have it do the heavy lifting for us. So it's going to be 0.8451 minus 4. Final answer is negative 3.1549. So approximately negative 3 point, I already forgot, 1549. 1549. Okay? So there goes your final answer. Alright, let's try another example. Example number 3. In this case, we're going to be looking for the log of, let's do log log 150. Okay, so log 150, what is this one going to be? So let's see, 150 if I break down, I know this is base 10, right? If I break down 150, what is that going to become? If I break down 150, that's going to become log base 10 of 5 times 3 times 10, right? 5 times 3 times 10. I know 5 and I know 10. What on earth is this? 3. Are any of these numbers I can manipulate to get 3? Like square it, halve it, double it, square root it? Any of these numbers? Oh wait, we have a 9 here, right? So what's the relationship between 9 and 3? Check this out. This is going to be log base 10 of 5 times 9 to the what gives you 3? 9 to the 1 half times 10. What on earth does this mean? 9 to the 1 half is the same thing as the square root of 9, which is 3. Okay? So this is a perfectly legal move to employ to get to this number right here. Okay? So since multiplication of numbers is addition in the log bowl, we're going to apply that rule here. So we're going to have log base 10 of 5 plus, see that 1 half is going to go to the front. 1 half log base 10 of 9 plus log base 10 of 10. Okay? This 1 half came to the front because when I took the logarithm, there was 1 half here, so I moved it to the front without wasting time. I did 2 steps at once. So this is going to become approximately 0.699 plus 1 half times 0.9542 plus, this one is just 1, yeah? Alright, so I'm going to plug this whole story into my calculator. It's going to be 0.699 plus, you see 1 half? Put it in parentheses, please, or else your calculator will ruin your problem for you. Fractions must be encapsulated in the parentheses, okay? 0.9542 plus 1, final answer, 2.1761. So our final answer is approximately 2.1761. Okay? Alright, so there you have it. Okay, so hopefully these examples will help you with the first part of today's classwork. Alright, welcome back, students. Now we're going to look at some examples on how to simplify logarithmic expressions. So, simplifying, write down the title of the notes, simplifying logarithmic expressions. Okay, so we're going to be using the formulas that I just presented to you all. Okay. All right. So let's take a look at some examples. Simplify the following. These instructions. Simplify the following expressions. All right. Number 1, we have log base 3 of 9. Okay, so the game we're going to play here is we have to match the number with the base. Okay, never change the base. So you ask yourself, how can I express this as a power so that it matches the base? So basically 9, how can I express 9 as a power of 3? That's not difficult, right? We know that 3 to the second power is 9. Okay, so this is the replacement that makes this number match the base. So this is going to become log base 3 of what? 3 squared. Okay, the goal is to make these two match. Do they match? Yes. Why do I want them matching? Because they're inverses and they cancel each other out. And your final answer is just 2. Okay? Alright. Let's try another example. Let's say we have 4 to the log base 4 of 3x. Let me write that bigger so that everybody sees that. Write it again. Log 4 to the log base 4 of 3x. Okay? So remember, exponents and logs are inverses regardless of the order. So this one you have an exponent and a log. These two are inverses, so you know what happens? They neutralize each other out, and your final answer is 3x. Okay? Remember the rule that we just went over. Alright, number 3. Let's apply the rule to this scenario. What if we have log base 4 of 2? What is that going to be? 4 to the what's power is 2. I know 4 to the 1 is 4. 4 to the 2 is 16. Wait a minute, these are getting bigger, right? I need an exponent that's going to compress this. So what power of 4 makes the number smaller? It has to be a fraction. What is 4 to the 1 half? 4 to the 1 half is just the square root of 4, right? Which is 2. So this is exactly what I want. So this one can be written as log base 4. Remember, never change the base. You can alter this number, but do not touch the base, okay? 2 is going to become 4 to the 1 half. Why did I use 4? Because I want these two to match. When they match, that gives me the right to cancel them out like this. And your final answer is 1 half. Okay? Alright, let's try another example. What if we had log of 27? Log base 27 of 3. Okay? Log base 27 of 3. So basically 27 to the what's power is going to give you 3. This exponent has to be a fraction, right? So that the number gets smaller. I know, what do I know? I know that 3 to the third is 27. If 3 to the third is 27, that if I raise both sides to the 1/3, guess what? That tells me that 3 is 27 to the 1/3. Does that make sense? It should, because 27 to the 1/3 is basically the cube root of 27, which is 3, right? So basically the replacement that will work here, 27 to the 1/3 equals 3, is the replacement that I need for this 3 right here. We're not touching the base. So I'm going to write this as log base 27. And then instead of 3, I'm going to rewrite it as 27 to the 1/3, which is the same thing as 3. But these two match. They give me the right to cancel them out like this. And our final answer is 1/3. Okay? Alright. Let's try another example. Number 5. Whatever we have, log base 10 of 0.001. If I want to write this as a power of 10, I'll just put this over 1 point. And then like what we did earlier in the class for today, I'll move this 1, 2, 3 to the right. Bottom is going to go 1, 2, 3 to the right. So you put a 0, 0, 0. So that's going to be log base 10 of 1 over 1,000. 1,000 is basically 10 to the what power? 10 to the third. Okay? That's 10 times 10 times 10 is 1,000. This is downstairs. I need to move it upstairs. What can I do to move it upstairs? If I negate the exponent or take the reciprocal, that moves it upstairs. Okay, so this becomes log base 10 of 10 to the negative 3. Have I accomplished my goal? Of course, because this number and this number match. So these two cancel out. And your final answer is negative 3. Okay? Alright, number 6. This is a new type of problem. Express the given logarithm as an exponent. Okay, so we can call it as an exponent or an exponential form, same thing. So let's do log base 4 of 128. Log base 4 of 128 equals 70 over 2. So I want to write this as an exponential form, So to do that, we're just going to use the opposite of log, which is an exponent. What is our basis? What is our basis of exponentiation here? The basis of exponentiation is 4, since that's the base, right? So we just put a big 4 on the right and a big 4 on the left, and these two gets exponentiated. Log base 4 of 128 is 7 over 2. This cancels with that, so you're going to have 128 equals 4 to the 7 over 2. Okay? That's all this question wants you to do. Just express this number as an in exponential form. So that's the goal. Okay? Alright, last example before we start on the word work problems, number 7. Express a given equation. Express a given equation in logarithmic form, or the logarithm already wrote, right? Okay. In logarithmic form. Okay, what if we had the exponential equation 49 to the 1 half equals 7? How do we write this in logarithmic form? In order to cancel out the exponent, we need to take the log of both sides. But what should be the base of my log? Whatever this exponent is, I'm going to take log base that exponent so that it matches and it cancels out. Since 49, I'm going to take log base 49 of 49 to the 1 half equals log base 49 of 7. Okay? So if you look here on the left side, this and this cancel out. You're going to be left with 1 half equals log base 49 of 7. Okay? So this is the original problem expressed in exponential, in logarithmic form. Sorry, expressed in logarithmic form. Alright, so that's that. Alright, thanks for paying attention to this presentation. We're going to go ahead and I'll start on the classwork for today.